In today's note, we're going to be looking at similar triangles. So similar triangles are triangles that, one, have the same angles, and two, the ratio of corresponding sides are the same. So what that means, so obviously the same angles means the measurements are the same, but what does it mean by the ratio of corresponding sides are the same? Basically that means if I were to look at this triangle here, these two here, they do look similar. We could check to see if the angles are the same, but when we're referring to the ratio of the corresponding sides, what that means is if I look at this side and I find the corresponding side or the same side on the larger triangle, and so I've both marked them in red, if this side was, say, had a measurement of 1 and this had a measurement of 2, you would say that the larger triangle, this side is double the size or 2 times the size. So that means if I were to look at this side of the triangle, of one triangle, and say it was 2, and I was to look at this side, it would have to be 4, right? Because it would have to be double. So basically all the sides on the larger triangle are always going to be double whatever the measurement is on the smaller triangle. So that ratio of 2, meaning that it's doubled in size, is the same for every single side. So that's what we mean by corresponding ratios, or the ratios of the corresponding sides are the same. Basically, whatever we increase one side by, it's also done the same for all the other sides. And I don't mean by adding it, it's by multiplying. Think of if you're trying to make an image bigger on the computer, or you drag it in the corner and you maximize it or you make it bigger, it's making every side bigger by the same amount. So if I look at these two triangles, triangle ABC is similar to triangle DEF, or if they are, then that means that angle A is equal to, and I'll do it in colors, angle A is equal to angle D, because those are the corresponding or the same angles. Angle C is equal to angle F. So these little kind of symbols just representing the angles. And then we'll look at B. So angle B is going to equal angle E, because those are the same angles, are in the same spots in the two triangles. So that's again referring that the angles are all the same. Now, when we're looking at the ratio of the corresponding sides, so I'm going to draw a line in purple to represent the 1. So this means that side AC, if I divide that by the side length of the other one, or DF, what that means is whatever that ratio is, so I can figure out the ratio by dividing, that's got to equal the ratio for all the other sides. So if I divide the other two sides, so AB divided by DE, because those are the same sides, or same in terms of the triangle, and let's grab another color here, we'll go rainbow, and I look at these two sides, again, they're the same, similar side, so I have CB divided by FE should equal the same thing. Now, notice how I've put the smaller triangle, those sides on the top, and the larger ones on the bottom. You can have it flipped, but it has to be all the same. So in this case, I have the top, or the small triangle, all the sides are on top, and all the sides of the large triangle are on the bottom. That's fine. If you flip it, all the large triangles on top, and I'll just write this out just in black. So D, I can do the same thing, just flip it. So DF over AC, but that also means then that I have to have DE over AB and FE over CB. So again, everything would have to change, everything would have to flip, it can't just be one. But again, you can see that the large triangle, all the sides for one triangle are on one side, and all the sides for the triangle are on the other side. So again, this is just an overview, or kind of the theory behind what makes a similar triangle. So let's look at an example. So here we're looking at triangle ABC, and this little symbol here, this approximation or squiggly line, this means similar to. So this means that we're telling you, or I'm telling you, that triangle ABC is similar to triangle DEF. We can see that all the angles are the same because they have the same symbol representing them. And what the question is asking is, it's asking us to determine the measures of side lengths F, so we'll highlight that, F and A. So what we have to do here is we know that because they're similar, the ratio of the sides are going to be equal. So first, we should have a side that is common, where we know both sides of this, or both the measurements. So in this case, it's AC and DF. Right? It's the same side. We can see the same two angles at both spots. So these are the corresponding, this is a corresponding pair. So what I'm going to do is I'm going to write those out. So 4/10 is one ratio, and this has to equal the ratio of all my other sides. So this is how I'm going to find the missing side. So let's look first here. We'll look at these two sides. They're the same size, or the same sides of the similar triangles, right? Because they both have the same angles, they're in the same spot. So now I need to place down my information. Because it's a ratio or division, I know I'm going to have to divide. 4 was on top, which is part of the smaller triangle, so that means the A would need to be on top because it's part of the smaller triangle. And for the corresponding side, 15 would be on the bottom. Now what I have here is an equation. I can start solving for A. So the way this works, easy way, if I have the number on the bottom, we talked about solving with fractions. I want to get rid of that, so I need to bring it up, or I need to multiply by 15. So I'm just going to rewrite it. So A over 15. I want to cancel out the 15, so I'm going to multiply this side by 15. I'm going to multiply the other side by 15. It cancels out on one side, and I'm left with 60/10, because the 15 times 4, still divided by 10 equals A. 60 divided by 10 is 6, which equals A. So that means that this side A has to be 6, because it has the same ratio, or it's in the same proportion, right? It's increased by the same factor. Now what I'm going to do, I need to find my next side. I'm still going to do the same thing. So I'm still going to put 4/10. And in this case now, I'm looking at my other sides. So the ones I've highlighted in red. So 4/10 is going to equal 5/f. Right? I've put the small triangle sides on top. I've put the large triangle sides on the bottom. And now I can solve for f. If you want to keep the steps similar to the one we just did, because the missing piece is on the bottom, you can just change this or flip it to 10/4 equals f/5. Right? Either way you do it is fine, but remember when we talked about previously, you can make sure that as long as all the sides for the same triangle are on the one side. So in this case, the large triangle is now on top, the small triangle is now on the bottom. That's fine. You'll still get the same answer. So if we work through, for example, on the bottom one, I'll just rewrite each one. So you can do either or. So I want to get rid of the 5, so I'm going to multiply by 5 to cancel out the division. It cancels out on one side. I'm left with 50/4 equals f. And then I'm going to go through the next one. Or yes, no, we'll finish solving this. So 50 divided by 4, we get 12.5 equals f. Now let's do the same thing on the other side. So this one's going to be a little bit trickier. Because I have the f on the bottom, I want to bring that up. So I'm going to multiply by f on the one side, multiply by f on the other side. Those will cancel out. I have f times 4 divided by 10 equals 5. I want to get the 10 by itself, or sorry, the f by itself now, so I'm going to multiply the one side by 10 to cancel out the division, multiply the other side by 10 to get the division, Oh, so it cancels out on the one side. I'm left with f times 4 equals 50. To cancel out the multiplying, I'm going to divide both sides by 4. One side cancels out, and I get f equals, again, the same answer, 12.5. So, actually, let me just separate this a little bit so we don't get confused. So I would say a good habit is we can see when the missing piece is on the bottom, it can be very difficult, or not difficult, but just extra steps. So when you're solving for a missing side, I would say make sure that the the missing piece is on top, because then it's just one quick step of multiplying, then dividing, and then you get your answer. So you just have to set up your triangle that way. If you set it up where you have the missing piece on the bottom, again, we just talked about with this example up here, just flip it, flip both parts, and then you should be fine. So let's look at another example. So in example 2, we want to verify or prove that these two triangles are, again, the squiggly line means that they're similar to. So looking at these, we don't have a lot of information. We do have one pair of sides, which we can see here. So we could find the ratio there, but we don't have enough to prove that the other ratios are true or are the same. We can assume they are, but we don't have enough to prove that they are similar triangles. So that means we have to focus on the angles. So if we look at the angles, what we can see, so this is kind of referring back to our angle patterns from grade 9. These two angles here are going to be the same because of the X pattern, so we can write that. So we can say the one dot for the two dots, so that we know that those angles are the same. We can also look at the Z pattern. So when we look at the Z pattern, right, we should know that when we follow the Z, these two angles are the same because of the parallel lines here. And we can also reverse it to do the Z pattern the other way. So in this case, these two angles are the same. So that's how we can verify that it's a similar triangle, because all the angles are the same. Really, that's all we have right now, and we'll assume that the ratios are the same as well. But now what we can do is now we can use the sides that are given to us and determine the measurements for our missing sides here, X and Y. So it may help to redraw this triangle because unlike the other triangles, these aren't in the same kind of rotation or orientation. We know they're similar, or we verified it, but they're not in the same kind of orientation. They're flipped, so it might be difficult to find your sides. So what we can do, we can just redraw it, each triangle. Again, it's not going to be to scale, but what we can do is we can put the dots in the right spot to represent the angles that we know based on the one above. And now we can label our sides, again, based on what we know. So we know going from the red and green dot on the small triangle has to be 9, and on the large triangle it's 13.5. We know on the large triangle from purple to green it's 12, and purple to green on the other triangle it was Y. From red and purple it was 10.5, and red and purple on the other triangle was X. So all I did was just redraw it if you have trouble visualizing which sides are the corresponding, or which sides are the pairs. So now what we're going to do is similar to the last question. We're going to come up with our ratio and use that to help solve for our missing sides. So we do know one side already. We know that for a small triangle, 9 right here again is corresponding with the bottom on the other side, so 13.5. So if I divide these two, it has to be the same, as if I do that for, let's say, this side here, which again, small triangle first, because the 9 was first. So we have x over 10.5. And now we can go through and solve similar to how we did in our previous example. Again, if you put the larger triangle on top and you don't like solving when the variable or the missing piece is on the bottom, you can just flip the two and you should get something similar to what we see here. So I'm just going to rewrite this. If I want to get rid of the 10.5 because it's division, I'm going to multiply both sides by 10.5. So they cancel out on one side. And on the other side, 10.5 times 9 is 94.5. I still have the divided by 13.5. And when I do that division, I get that x equals 7. So basically that's saying based on the ratio of the sides I know, the one side on the small triangle x is going to be 7. Right. Now the next one, I'm going to get a different color. So we're going to look at these two corresponding sides here. Oh, sorry, I missed the one on the large triangle. So rainbow and rainbow. So we're still going to use that initial pair that we know, so the 9 over 13.5. And when I'm trying to find the other one, again, I'm going to set it up with the small triangle first. So that side is y divided by the other triangle side from the other triangle, which is 12. And now I can solve my ratio, or basically solve my equation. So I'm just going to rewrite it. So 9 divided by 13.5 is equal to y divided by 12. If I want to get y by itself, and to get rid of the divided by 12, I need to multiply by 12. Do the same thing to both sides. It cancels out on one side. 12 times 9, I get 108. It's still divided by 13.5. Y is by itself. And when we divide, we get that y equals 8. So these are our two missing sides. So again, we're just basically ensuring that they're similar triangles, setting up a ratio or basically a fraction or division of sides, of corresponding sides or matching sides that we know, and then using that to help us find a missing piece of information. And again, that's basically the introduction to similar triangles. Again, remembering the ratio, or if I divide corresponding or matching sides, the answer should be equal to if I divide another set of matching sides, and that in the two triangles, all the angles are the same.